Okay, welcome everybody to this webinar. I'm very pleased today to talk to you about an enhancement of IBM Planning Analytics that I've been working with. And it's all around how to use the REST API and Python to extend your solution that you're already using, or to understand how IBM Planning Analytics gets extended with this module further. Okay, so how is it structured? I will give you an overview of the extension first and explain some areas where this could be used in, and take some conclusions on the theoretical part with you. And then I will show you 3 use cases where this new extension could be used, for example. I will talk about for half an hour, and after that you will be able to write the questions in the chat, and I will go through that and try to answer as many questions as possible. This is also recorded and will be available to you afterwards, after the presentation. So before we start, very quickly, who is the presenter? I'm Olivier. I have studied finance, business administration in Switzerland, and I worked the last 6 years primarily planning a planning system for EF education. We have spread it through the whole global organization. So I've been very much exposed to IBM Planning Analytics over the last years, and during the last year I have worked and also with this additional extension. But I worked also with a lot of other areas in finance and IT, and I started now with Advectus as a consultant in January in Sweden. So I want to give you just a background. I come actually from finance, became more technical, so I want to also always emphasize a bit from a controller perspective what the use case could be around this extension. So you might already be using IBM Planning Analytics, or you might be listening in without using it yet. But IBM Planning Analytics is a platform to do planning. It's not only financial planning necessarily, you can do operational plannings. This year, for example, I worked on a small scheduling tool for Ambulanzen in Skåne to schedule their staff. But it is very broadly used in many industries, and it is very powerful in the background to model, to do calculations on a big scale, and its flexibility is usually not matched by competitors. Nevertheless, there are, in my opinion, 2 areas where IBM could become better. And one is how they present everything, the front end, and they have done some improvements by introducing planning analytics from TM1 perspective, and I think they are working on extending that front end further, so you will be able to create more visually interesting dashboards for your management. The other area they have been lacking in the past, at least, was the interfaces with other systems. So if you want to load or send data, before you primarily were limited to text files, CSV files, and a database. But they addressed that about 2-3 years ago when they created a REST API around that. And this is just an interface where you can interact with all the basically modules and components in TM1 and develop things towards it. But this is still very interesting primarily for developers that want to integrate it with other systems. And an additional tool was created by a smart consultant, which brings Python into the game and basically interacts with the REST API using Python. So basically, what it means now, going a bit away from the technical terms, is that so far you were using Planning Analytics with its native developing tools and possibilities. IBM extended that by creating an open interface where developers can create new tools against it. And a library, a wrapper was built around that, which allows us now to write in Python and interact in Python with Planning Analytics. And this is, first of all, from a technical perspective, exciting. But if you're a controller, well, what does that mean for you? Well, first of all, what is Python? Python is one of the most popular languages which is out. And why is it so popular? It's because it's lean, clean, easier to learn and to maintain. And again, from, let's say, an IT perspective or a financial project plan, it means that you will be faster in implementing new things. You will have less maintenance. And what I will focus a lot today is you will get a lot of additional tools that you can use for free if you know how to integrate them. And since Python and all these tools are open source, it means that it comes without additional license costs. So, okay, so far you heard something. Okay, there is an extension, an interface, Python, so I can develop in new ways in IBM Planning Analytics. A little bit more specifically, what does it mean for your solution? I think there are 4 areas where you can extend your solution thanks to this tool. The first, and I think the most powerful, is you can bring advanced analytics to your planning solution now. So Python has a lot of libraries to do predictive and prescriptive forecasts. And that means that you can extract the data now from your TM1 and with a button, basically just send it out to an analysis that you will build or let be built in Python for your specific case. It runs through these scenarios, brings the data back into your TM1, into your visualization, and you will be able to basically have completely new angles and views at your data and new insights around it. What is also large areas, you will have a much easier time now to integrate it to other systems. So, for example, you can load data directly from websites. Let's say if it's FX rates, if it's share prices, if it's commodity prices, if it's also to integrate it with other solutions that you use internally, other databases. Let's say also if you want to send data out of the system of TM1, it will be much easier. For example, if you have Power BI as a front end or one of the other front end tools, it is now possible to directly and live send data from TM1 to these tools, thanks to this TM1 Pi and Python integration and that TM1 now has. A third area is you can now also choose to do a lot of the scripting instead of doing them directly in Planning Analytics, to do that in Python. There are some areas where Python is just much more powerful, like when you need to do mass changes to a lot of your modules in Planning Analytics, when you want to do some any kind of functionality which is not natively available might most probably be accessible now thanks to this tool. And a fourth area is if there are formulas outside TM1 that you were not able to use before because TM1 does not have these formulas, now thanks to the integration, basically any kind of formula thanks to Python will be available, and I will also showcase an example there. You could theoretically even go further and create some new web components in your planning analytic tool, and that would mean, for example, that you could show some more advanced graphs in your front end. So to summarize a little bit, do further and deeper analysis, integrate it better to your solutions that you have or data that you need to pull in. Facilitate your maintenance or facilitate also mass changes and enhance functionality by adding new formulas and or web graph components to your front end. So these just are umbrellas, and below these ones there are many possibilities based on your solution and your interests. Just on the first one, advanced analytics, I want to show you another graph which goes a little bit on the planning cycle and what you usually do. So many of you probably are using the solution already to plan and forecast your year, and then you use therefore the IBM Planning Analytic tool. And to understand what happened, you will pull in actuals from your transactional databases, from your ERP systems, and perhaps some sales data from your CRM and so on to compare what happened. And then you will start to try to analyze why this happened. So you will try to find the drivers around that with waterfall charts, perhaps visualize that in a nice way as well. And in many cases and many companies, I saw that a lot of the effort is to at all build up this area, and this area is comprehensive, and if it's well done, it can save a lot of time. But I think it's even more interesting if you don't stop the wheel there and you try to close the wheel by going into predictive and prescriptive with these additional tools that are available now to you in IBM Planning Analytics. And what does that mean? It means that instead of you then starting to plan the next year from scratch, or that you copied the prior period, you could use some machine learning and artificial intelligence with these libraries that help you to pre-populate your new year, not just with the past, but with a, let's say, mathematical and statistical approach to give you a forecast which is in line with the trend line of the prior years. And many are trying now to add this predictive part to their business. And once you succeed, you are a big step further. But I think what you should try to do as well is then to get the tools to give you suggestions what you should do. And that means that you should not only get what is probably the volume or the sales numbers that you will get and the seasonality around it, but how should you, for example, change your prices? When should you do your discount rounds? When should I plan to employ additional staff? So let the tools and the statistical powerful libraries which exist help you with this. Then what you will still do is look at the reasonability, try to tweak it further, and put some targets on it but at least you get a full cycle pre-populated by advanced tools with best practices used by a lot of companies to optimize their budget cycles. And this is what gets at least me as a prior controller and now as a tool specialist excited, because I know it is now all available within the tool you're already using. So you don't need to install and buy additional tools. You can just use TM1 as you have been doing it. Just basically install this free tool, and then either you have to know how yourself in Python how to build it, or with consultants, and analyze the case and extend that in these additional tools to get the result back to your planning tool. So at the end, for the business user, for your management, or even for you as controller, nothing will really change. You will just get all the results back in IBM Planning Analytics, but in the background, we went actually out and used new tools, and this was just not possible before. And all of this also helps you to do an integrated solution and do everything within one tool, and not try to buy many different tools to do the whole cycle. So I know it's a lot of theory, and it's perhaps not super tangible for you yet. I will try to hopefully change that a bit by showing you some examples. But I will summarize before I go to the example what I think the main advantages is out of it from a controller perspective. I think the main thing is you want to, with the data you have, if you have good enough data, you want to start getting new insights out of it. So analyze it from different angles, use different mathematical, statistical possibilities to get new insights from the data you already have. Then also accuracy. I mean, a manual approach can rarely beat a machine or a statistical approach. So it has, in almost all business cases, always improved accuracy significantly, which then leads hopefully to better business decisions. The new insights, by the way, are also primarily there to motivate the management to find better management decisions and business decisions around it. One aspect which is always very relevant, well, if you get your budget cycles pre-populated in a qualitative way, then you will save a lot of time, and you can start your budget cycles right away on analyzing the data instead of compiling the data. I mean, it's not a tool which will solve all your problem in one go, but it will help you in a lot of areas to become much more efficient. And then, as I said in the prior slide, use also the tool to optimize your decisions in a mathematical statistical way. And of course, if you don't know the technology well, it could also lead to questions, sounds complicated, or what does that mean project-wise? I think depending on the business cases, it can be very quick to set up. It can be anything from a few days to a few weeks. So the examples I will show you now, it's a matter of a few days to build. And advantages, as I said before, also is you have no extra licensing costs. You have development costs, but they will probably be not so recurrent. And also changeability. Let's say if of course your dimension changes, your product structure changes, we can still make it in a way that most of the changes, if not all, you can still maintain within planning analytics directly and try to build it in a way that only if you want to really use other statistical methods, then we try to expand the Python solution again. Otherwise, we always push to get as much maintenance or changes done within the environment you are already used to. So overall, I think it can bring you very fast return on investments with relatively small investment numbers. Okay, so good. Then let's go into the examples. I have actually a live environment I can go to, and I have 3 examples I would like to show you. One is how to import or use a new formula that didn't exist before in planning analytics. The second one will focus on predictive and how to predict a timeline. And the third will focus on optimizing your production schedule. So this is something I've done in a prior project where this client was very interested to get a distribution of their investments based on a timeline and the distribution type. So it was large investments, and they had a very specific requirement what formula needed to be used. And for the ones that are interested, this was the beta distance formula, which looks cryptic, I guess, for anyone which is not a mathematical genius, I guess. But it basically just puts on a timeline the investments in a specific manner, how the customer would like to have it. So if I now go back to the example, here you can see I define in planning analytics, you see, what kind of distribution I would like to have. So let's say this first has a normal distribution, and the third one has a late skew. And let's also change number here and put something else. So now, basically, without this additional tool, you would not be able to run through this formula. So what I would do after building that, I would put a button here, you would push the button and it would refresh and do all of these calculations, and you would not even know that this left the environment to go through this additional tool. So now you don't need to understand the tool or basically be interested really in it, but basically this is how it looks in Python. And what I do here now, I have here the definition of that specific formula. I extract the data from TM1, I apply it, and I send the data back. So I just run this now from this environment, but I do that only because I want to show you that this is not done within TM1, but this is done outside with this additional tool. And you see it pulls the data that we changed into here. And now I go back into TM1, into Planning Analytics. I refresh. And basically, it basically does the distribution on the fly, so you don't need to care what happens in the background, but you can use now any possible formula to make the changes. A second example I would like to go into is predictive forecasts. And here, basically, we have an example which I use from a library which comes with the standard package that you can install, TM1Py package. And in here, what we do is we use a few of the use cases you have seen before in the overview pages. So we first of all go and import some data from a web page. And what we do here is we import some weather data. And why we do import weather data in this example is because we have a bike store, and this bike store basically rents out bikes, and we want to understand, does weather and season have an impact on it? And this is something that you usually would do with data science. But this example shows you how it interacts with TM1. So we pull some data from a weather page, and we write this data into TM1. Then in another step, we pull the data from TM1 again, and I just quickly run through. I just want you to have a very top line picture of what it would mean. So we pull that data out from TM1, and then we have a look at it. And this is a library, a graph library, which is called Plotly, which could also then, if interested, be put on Planning Analytics to have more advanced graphs. And what we do in this example is that we understand, okay, is the bike share in some way seasonal? And we can see, yes, the bike shares apparently is much more borrowed in summer than in winter. So when we know that, we can go on and do some additional analysis. So now we bring in specifically from the weather data we loaded daily weather temperatures in, and we plot that to see how it looks, and we say, yeah, okay, summer is warmer. That's not a big surprise. But what is interesting for us is then to calculate correlations. So how is the bike share in mathematical terms related to the weather? And if we would, if we are experts in this, we can read, yes, it's highly correlative. So we know we are on the right track. So then we try to plot it, and we have 3 different cities. And in the 3 different cities, we can see different patterns. But we can see that, for example, Washington and Chicago, they are quite linear, whereas New York seems to be a little more spread out. Again, from a data science perspective, this just means that I will need to use different data models for the different cities. But what we have learned just from this very quick flyover is, okay, we know we have some data here. It is seasonal, it's weather dependent, and it's different by city. So once we know that, a data scientist within the vast libraries in Python will be able to guide you and say, for this type of analysis, there is a library, for example, from Facebook called Prophet, which is specialized to forecast timelines. And what they do is see seasonal trends. They see also specialities as holidays. So another graph that I'm showing you here shows you how the sharing goes on working days versus non-working days. And what we have here is that we see many more green dots below the line, and this means that basically on holidays there are much less borrowings happening than on working days. So we have now different information, and a data science would put those now in the right parameters in the library of Profit, which is available through this extension. And what the end result is that the black dots are data points that you had already in actuals in your model, and the blue range is how this method found the pattern. And these two areas now behind here basically predict how it will probably continue. And you can already see it would probably be quite hard to do this in a manual way. And this, though, calculates you all of these points and then writes you at the end of the story back this result into TM1. So despite the many graphs you saw, the only thing I want you to take along now from this tab is that you have a history which is seasonal, which is based on some parameters like temperature. Holidays matter. So would it not be great if that could extend to the next year with the right holidays, with the right seasonality in an automatic way? Sorry about that. And that can be achieved actually by you just adding this extension, define this model together with a data scientist, and then at the end of the day, you will only adapt a few parameters in Planning Analytics, push the button, and you will get that in one simple go into your solution. And another final example, and I know I'm showing you a lot and I'm jumping around. I'll try to summarize it once more at the end, is an optimization. So we went through an example of additional formula. We went through an example how to do a timeline into the future. And now I'll show you a last example, which is an optimization example. So imagine that you have two production sites. It can be two machines, two plants. It can also be two products. Just two different production possibilities that you have, and you have some min and max capacity around them in the different months, and you have a variable cost and you have a fixed cost. And now you get from sales a forecast for the year, which hopefully ideally will use the prior methods that I've shown you just a moment ago. And now you want to know which of the two machines do you want to, or production sites do you want to use to have the minimal costs. Of course, you could try to do it manually. And I jump to the next one. And in here you have the first two tabs, which are the same. And here we have a manual approach where in the first months, for example, we need to produce 120. And we could say out perhaps of historical reasons, you have done 80 in the first site and 40 in the second site. And if you do that and you multiply by the fixed cost and the variable cost, and the fixed cost just get activated if you use the plant. If you don't use the plant, you have no fixed cost. You could, of course, add an additional column which says fixed cost in use, fixed cost not in use. You can extend it in many ways, but let's assume if you don't use it, the fixed cost is off. So in this case, then it just calculates fixed cost and variable cost, and you get to a production total. And if we run now this optimization script, that will look very similar to the scripts you've seen before, but for you it will just mean that you will have a button here and you will push it. What will happen is it will make you a suggestion, and this suggestion, it already changes the distribution and says, no, let's do more in production side 2. And if we look at it, it is also even logical, and in this perhaps simple enough example, you could achieve that manually because the variable cost of the second production site is much lower, although the fixed costs are higher. It probably is worse to produce because the difference is so big, but you need still to do these calculations. And here it basically says the optimization based on a linear regression gives you, this is the optimal distribution, and you can see the result. Yes, you save money. And on the overall year, you can see that just by optimizing that with this mathematical method, you can save about $1 million or euros or SEK in your production. And this is now a simplified example where we have not many constraints. We have only min and max capacity. You could, of course, add many more aspects like employment or employees availability, material availability, material seasonality prices. You can make it really complex to the level where this manual optimization to this variable cost is lower, I can probably achieve that myself, will not be possible. But with the mathematical way, you will get this. And I also added another example which extends it further. For example, let's say you have a third plant available, and the third plant increases your possibilities to produce. Let's assume that the sales forecast remains the same, and this plant either was received through a merger or acquisition, or you're thinking to buy this. So if we add this, keeping the other two, let's run the same optimization, and since the third plant has very low fixed costs, could be interesting, although the variable costs are not the lowest of all, is it worth to acquire it, and how much could you save? And if you run it through this optimization, the result is that you see in January now, instead of doing 70-50, it suggests to do 40-50, 30,000 in distribution, and the overall cost goes even more down, which could be counterintuitive if you say you have a third plant. Is it really cheaper to have the third plant? Well, you save you save basically 90,000 in this case, and in the overall year, you see you save about 1.5 million. And now, if you know you save 1.5 million, you can of course say, is it worth to invest? You can of course then put them on a timeline to net value investment calculation. So of course you will extend this to your very specific business case with all your constraints and parameters. But it then can just show you also in a visual way that if you use this kind of tools, there is a huge potential for you to save costs and take better decisions based on that. So a lot of information, perhaps even too much information in so short time. If I try to summarize, top line, what have you heard today? In my opinion, what you should have heard is there is an extension to your IBM planning solution. This extension brings Python into the game. With Python, all these optimizations, integrations with other tools, formulas become available to you in TM1. As such, you get just a much better platform with so many possibilities. For your budget cycle, this though means use the new possibilities to save time, to get better insights, but primarily to optimize your numbers with advanced data science. A lot of companies are already doing that. You can do that all within TM1 now, or I use a lot of TM1, that's the old name, of course, Planning Analytics, with a relatively small investments probably from your side. So I think if you have questions, you can put them into the chat now. I think also it will, you can of course reach out to us as well, and we have also discussions on a one-to-one basis on your specific cases. Yeah, don't hesitate to reach out to me or to Kerstin or to the contact person you have at Advectus. And hope you have got good insights into today's new possibilities, and looking forward to hear back from you. So please, any questions into the chat, and I will try to answer them right away.